Yes, hi. Hi everyone. Good morning. All right. Uh, we'll first begin our session by understanding what is machine learning, what are the roles and responsibilities of data scientist that one need to be one need to perform in an industry. So let us consider this scenario. It's very interesting. For an example, let us consider how the day in a data scientist life or data analyst life goes like. We'll just see this, right? So how typically data scientists or data analysts spend their day in the industry, or what are the roles that they need to perform? We need to understand this. So basically, this is known as, in technical sense, this is known as uh, crisp dim crisp CIRSP DM framework. But in simple words, in layman language, you can consider it as data science framework, right? Or data analyst framework. So how we generally take up any data and how we proceed further, we'll try to understand. So this is common for all the applications out there, not only related to any sector. This is common to all the sector out there, right? Now, the very first thing is known as business understanding. So we'll divide this into several steps. Let us consider step number one. So for an example, we get the data. I'll tell you from where we get the data, or what are the different ways in which you can extract the data as well. So first step, let us consider it as business understanding. Now in this thing, you understand the problem statement, you understand the data, you understand the overview of the overview of your business. For an example, let's say we have a data in which we have customer, we have day, we have browser, we have number of clicks, pages viewed, time in minute, and amount spent, right? So this is a data we can consider as an electronic segment data. So how many customers do we have total? We have 43,200 customers. The day that typical customer is browsing or signing into that particular website, we have that day. We have a browser that customer is using. Number of clicks performed before purchasing a product, we have this. We have pages viewed, which are nothing but 4, 5 before purchasing a product. How many pages he has actually visited. Then we have time in minute, the time in minute that he has spent on that particular website, right? And we have amount spent for that particular customer. So for an example, you are being customer number one, sign in this particular uh, website on Monday. The browser that you are using is Chrome. Number of clicks is 13. Pages viewed is 4. Time in minute is 8.5 minute. And amount spent is 2668 rupees. Right? So I'll just demonstrate how this data is getting generated. Right? So for an example, let's take a Samsung website. Right? You are interested to purchase something from this Samsung website. So what we'll do is we'll go to this website. Suppose you are being customer number 43201. You are 43201 customer. 43,201 first customer. So you'll go to this website, Samsung. And the very first thing, suppose I'm interested to buy some, let's say, mobile, right? I'll go to this click number one. Let's say I'm interested to go for this. Click number 2. Then we'll select something over here. Click number 3, 4. You'll provide this. 5. And click number 6, 7, 8. You perform this. 9. You'll feel this. 10, 11. 11 or 12 clicks are there. And the amount that you are interested to go with is 19,999, right? So at the back end, there will be a data extraction generated. I mean, data is generated, and this information will be filled like this. For an example, let's say you are this customer 43,201. Today is Sunday. The browser that I'm using is, let's say, Chrome. What is this? This is your number of clicks. So as we have calculated, we have approximately performed 15 clicks. Pages viewed are 5 or 6. Time that I spent on this is, let's say, 5 to 7 minutes. So 7 minutes and 99999. Right? So this is how the data team will collect the data. That's not your responsibility. Going further with the course, we are going to understand several ways in which you can extract the data that we'll see. I'll help you out at that time as well. I'll give you a few websites from which you can download the data as part of your analysis. So there are several jigs for getting some data from government websites. We'll see that after some times. Uh, then we'll see how do you get the real data, not dummy data, which is available on Kaggle. So I'll tell you a few websites for that, right? But this is not right now. Going further, when we are going to see some cleaning part, EDA part, at that time, we'll see what is it, how to extract this data, right? But as of now, consider as a data scientist, this is not your responsibility to get the data. That is very first thing. We generally directly get the data from our different team, which is there in our organization. So that's not your responsibility that to generate this data. We have some data annotator which company hires generally. I'll tell you a few scenario from my industry perspective as well. We were working on a project which was related to Amazon. I'll tell you a few scenarios in this upcoming sessions as well, like how we proceed further with the project, what are the different things that we do, how many teams were there, how data was generated, how did we get the data. We'll discuss this everything, right? So not only theoretical part, I'll be discussing a few stories related to my uh, our projects that we have completed. So it will be interactive session. It's not just theoretical part. I'll share my experience uh, related to those projects as well. Yeah. So coming towards the first step, which is business understanding, we understand the problem statement over here. So let us write down understand the problem statement. Now, can anybody guess what would be our problem statement in this particular example? What can be your problem statement in this example? We have an electronics data. So what can be a problem statement? Karthik is saying chart or analysis. Yeah, but I am expecting more specific answer, not general answer. Generalistic answer I'm not expecting. Yeah. Think from a business perspective, as a data analyst or a data scientist, customer behavior. Yeah, but uh, I want a line, a one liner. It's not just the popularity of a site or a product. Okay.
Which customer has an highest purchase?
Which customer has highest purchase? Very good. Excellent. So obviously, suppose you're running an organization. Your organization, what it will target? It will target the amount spent based on the time spent from a particular website. Very good. Highest items sold out. For an example, let's say you are working as a data analyst or scientist in this organization. So, as a data scientist, as you work with the data, your ultimate target is to maximize the profitability of the organization, right? The reason why we are extracting the data, why we are performing some analysis, why we suggest the uh, conclusion, insights, inferences from the data is we have to maximize the, or we have to create some strategies, business related strategies, by using your programming knowledge, by using the machine learning concepts, by using different charts, statistical analysis. What we do is we do this technical part, and obviously the non-technical guys, which are their management level guys, they will not aware about the technical terms. For an example, if I say to, if I just uh, conclude that p value is this much, or my correlation coefficient is this much, or let it be any technical terms, it will your management level will not understand that, right? So what you have to do is, from that inferences, from that graph, from that analysis, you have to write down simple level solution which anybody, any layman can understand, right? So you first do the analysis, you plot the data by using obviously different programming language. You go with the Python or you go with the SQL as well to play with the data. And from that analysis, you not only just do the analysis, you write down in simple terms, you write down in bullet forms. Point number one is this, point number two is this, point number three is this, right? So this is our task, to do the complex analysis and to put the conclusion in very simple term, right? So that is our part. So in this thing, we'll see what is our problem statement. So let me write down problem statement over here. The problem statement is, or it could be for this data, is we have to maximize the amount spent in rupees, right? How we can maximize this? We'll understand the relation between your amount spent and this different uh, variables that we have. I'll tell you what is variable, but we'll just predict the amount spent by using these different columns, right? So this could be another problem statement. More technical sense, we can talk about how we can predict the amount spent by using this variable, right? So we have to maximize the amount spent. Now we'll do very generalistic discussion with our team or management that we have this data. Generally, what happens is in the industry, I'll tell you our scenario as well as other scenario. What they do is they get the data, they just jot down the problem statement, and the technical guys or the management level guys uh, want you to prepare a slide deck, so that how you will you approach this problem statement. So you have to create 10 to 15 levels, 10 to 15 slides for this, and you have to use your technical expertise, so that how you can go with the problem statement, right? So they'll tell you this thing. You have to identify. Suppose you are working in a team of 5 or 7, you guys will divide that work, and you will present this to the higher authority or manager, and they'll ask you questions on that, like what if this does not goes with, or this does not aligns your plan, right? So you have to face that particular round first of all. In EY also they do same thing, and in other organization also they might be doing the same thing. So yeah, so you have to create a visualization, a slide deck for that to explain how you will proceed further with this problem statement, right? And it's very easy, as you guys will understand all the concepts out there. You can easily tackle this problem from your expertise, right? So we'll just discuss this with the team, right? So I'll just highlight this. This is your step number one, very basic step. Now let us go to step number two. So what is your step number two in this CRISP DM framework? We have to understand the data. So I can say it as data understanding, or I can write down as understanding the data. Yeah. So in this, the very first thing is, if I talk about the technical sense, technical term, your columns are known as features. The columns in your data is known as features. The rows in your data is known as records, right? So remember this thing. Whenever in the upcoming sessions, if I talk about this, we have n number of features or we have 5 features. So you should understand that it is known as columns, and rows are nothing but records, right? So you'll get habitual to this. It's not that uh, a topic to worry about. But as of this, at this particular point of time, just understand the columns are known as features, uh, and rows are nothing but records. So we'll just see how complex is your data. So in this data, we only have 43,201 customers, right? So we can write down we have number of records is equals to 43200, and features are 1, 2, 3, 4, 5, 6, 7, right? Now, coming towards the more realistic part, the data that you get, the data that we work in the industry is not this simple, right? It is having millions and billions of records sometimes. First point. Second, the data that we get is not this much clean. It's very, very, very unclean, right? Why I'm emphasizing on this particular point, it's very unclean, because we are unfortunately we are we wanted to extract information from the data. So the realistic data is not this much easy, right? This is our 95% or 90% time we spend actually on this segment, on this part. What is this part? Cleaning the data, right? Now going further, we'll see different types or different methods to clean the data. But I'll tell you at this point itself, this is very, very important part. So if you become expert in this, if you spend your time exploring this particular point, if you give more weightage to this, your half of the task is done, right? The next part, which is building machine learning model, using machine learning models, fitting that models, predicting the target variable, deploying the project, that is very simple. It's very easy task, right? But this cleaning the data by using different techniques, it's ultimately a challenge itself, right? So for this part, we'll be discussing this thing in very detailed manner, but you can explore from your end as well, or you can mark this as very important part. You can highlight this part. So which is your cleaning the data. So we understand the data, we get an insight about the data, we learn few shortcuts to explore the data, and we classify the data. So this is your step number two. So in this thing, you can bifurcate this as data classification as well. Now, again, very important part, as I told, cleaning data requires 90% of your time and focus for the entire project. Let's say you want to complete a particular project in 30 days. So you will surprised to know this fact that we are spending our 15 to 20 days in just cleaning the data itself, right? 15 to 20 days we spend in the cleaning the data itself. It is as difficult as this, right? So 90% of the time for this particular project, will be spending on cleaning, and it's very unfortunate. You guys will be getting very frustrated at this particular point of time. Like, how should I for clean the data? And yeah, this is ultimately a challenge itself, right? Now, in data classification, you should know different types of data that obviously we are going to discuss in details in your statistics part or your machine learning part. So there are different types of data. We have to classify the data. So as of now, let's restrict ourselves with the simple discussion. We have categorical data and we have continuous data. So what do you mean by continuous data? What do you mean by categorical data? Categorical data is a data which can be grouped further. For an example, in this case, we have browser. So in browser, we have a text kind of data, right? We have Chrome, we have Firefox, and we have Internet Explorer. In continuous data, it is your numerical data. You basically deal with numbers. So to give an idea, to give an example for this, we have number of clicks, we have pages viewed, time, and amount spent. Number of clicks, pages viewed, time, and amount spent, right? So we can write down over here example number of clicks, pages viewed, time, and amount spent. This is your numerical data. Now, one more thing, I'll just uh, give you a basic overview of this categorical data. Our model will not understand the text data, right? Humans are very expert, or they understand the data, they understand the text, they understand the language. So humans are expert in text, but your computer or your system is expert in numbers, right? So you can consider this very generalistically, because moving further, we are going to go with the AI deep learning part as well. So humans will understand photos, images, and text easily, but your computer, your system will not understand photos or text into text. It cannot read, obviously. So what do you do is you convert your text or images into a numbers, right? So for images, we'll see it afterwards. That is not a part of a concern as of now. But text, this is our text data: browser, Chrome, Firefox, and Internet Explorer. So we convert this data into numbers, right? And that is a different challenge at all. It comes under your data preparation or data cleaning part, which we call it as EDA, which is known as exploratory data analysis. And as I said, I'm highlighting this point again and again. You will be exploring your time, you're spending your maximum time in this EDA part itself, right? So this is very, very important step, EDA, right? So in this thing, you'll clean the data. There are several unwanted records in your data. You might have blank records. You might have a record which is not at all suitable for this data. For an example, you will surprise to know this fact that in browser, you can expect numbers as well, right? So you can expect few numbers in this browser column. You can expect few text in this number of clicks. So the data is not this much cleaned. We have to put some logic to understand the data, or to convert your data into legitimate format, right? So this is what we have. We have n number of steps. As of now, I'll not discuss the technical part. I'll just restrict myself with the general discussion over here. So second step is your data understanding. And as I've given more focus on this, because this is very, very important thing, right? Now you go with the step number 3. And yes, this data that we have, categorical and continuous, it further gets classified into different types, which is not uh, important as of now for you. We have several types for this continuous and categorical data as well. it gets classified into different type. So basically two types further we can have for this data, right? But that we'll see it afterwards, not now. For a day one, it will be, let us keep it very light. Now, the next is data preparation. So this step comes in hand with your uh, data understanding part. So data preparation itself has cleaning the data, uh, check the validity of the data. Data validation should be there. Validation means you can have a specific records in that specific column itself, right? I'll give you one example. We were working on Google Play Store data. It has more than 50,000 records, and we had ratings for the particular app. So we have serial number, we have app name, its criteria, whether it is for kids or adults. It has downloads as well. It has price of that in-app purchases. Then it had the size of the app, and there are n number of columns. I am not able to recall as of now, but ultimately you had rating, right? So we are interested to do analysis for this Play Store, Google Play Store data, and we wanted to come up with the useful solution so that uh, how your rating is related to these different aspects. We want to find the relation between that. So the reason why I'm explaining this is because in app name, in downloads, the data type, it should be in numbers, right? Downloads could be 5.5 million or 100 million downloads, something like that, right? And here we had dollar 0.57, something like this. So in price itself, we had size 956 MB, something like that. Price. So it was mixed kind of thing, $0.6. And in size, we had rating. So we did some operation, technical operation to clean this data. It should not be like this. Again, the data type for this downloads, it should be numbers, but it was object, it was text. So we converted this data into number by using Python. Obviously, we used as type function and we converted that into integer. But yes, I'll just share this case study as well. Once we go with the data cleaning part, we'll see that. Uh, so we clean the data, we check the validity of the data, we do n number of operations over here to just prepare the data, which should be, which is very good to fit the fit for your machine learning model, right? Now we have data analysis over here as well. In data analysis, you analyze, suppose it's a categorical variable, analysis of categorical variable. So it should be done with the use of pivot table, and analysis of your number, the continuous data. It should be specifically done by your descriptive statistical analysis. Now, what do you mean by descriptive statistics? Statistic itself holds very key role in this domain. So majorly we have two types of statistics which you guys will be learning further. We have descriptive statistics and we have inferential statistics, right? Descriptive is nothing but very same thing that you have learned in your school as well: mean, median, mode, variance, standard deviation. But let's not restrict this statistics in just uh, in the terms of formulas, right? What we know is mean is total number of observation divided sum of total observation divided by total number of observation. Median is nothing but your middlemost record. Mode is nothing but a number which appears maximum number of times. But let us not just restrict ourselves with this discussion, because we have learned statistics in more uh, formula way, right? In more formula sense. But the statistics is used here to come up with the business scenario, or to explain your statistical term in business scenario. So you should learn your statistics. You should learn mean, median, mode, variance, standard deviation, skewness, kurtosis, so that you should know their significance, how it will help you out in taking up your decision in your business, right? So it's not like we calculate mean. We will not use that. We'll use this mean. It tells a different part of story, right? It tells median. Median will help you out to take up some decision. How it help you out, we'll see that. So that's the reason we use statistics. It's very important part, right? Inferential is again very, very important, but it is somewhat little heavy to digest. We have uh, something which is known as probability. I know probability is uh, it's very boring, but again, it's very important, right? It's not just like to calculate probability of head and tail. We already know that, but we use this probability. We use binomial distribution. We use continuous distribution to uh, take up some decision, right? And this is a very important part. Here we have hypothesis, which you might know. We'll see that hypothesis testing. We'll see n number of use cases, n number of examples, real life example, how people have actually considered this hypothesis example to take up their decision, right? So there are n number of example we can see how we have used this hypothesis testing, inferential statistics, to apply or to use or to come up with some useful information from the inferential statistics, right? So in our project as well, we generally use this. And there's something which is known as sampling theory, which I know many of you guys will know about. So we'll see that in statistics, right? So coming towards your data preparation, we clean the data, we check the validity of the data, we do analysis, we go with the some charts, useful charts by using Python or any BI tool. We analyze the data, continuous data by using statistics. We'll see that, right? Now, this ultimately after this, after data preparation, your task gets easier. So we have step number 4, which is nothing but we can say as model building. We build the model. Now, in this, we'll use our understanding of machine learning. So there are uh, different types of, this is also known as predictive analytics. Predictive analytics. It means we are interested to predict something, right? So we have prescriptive analytics, predictive analytics, and we have other type of analytics as well. Predictive means we are interested to predict something. So that is known as predictive analytics. And obviously, I'll not discuss machine learning in this session because you guys will not have any idea about that. But let us restrict ourselves with the types of your machine learning, which is supervised, which is unsupervised. And there are several algorithms, there are several ways, multiple ways in which we can perform the model building. So we have regression kind of thing. We have logistic regression. We have clustering over here. We have PCA approach. And we have decision tree, random forest, and number of algorithms, which you guys will know in machine learning, right? So that's what we have for model building. I'll tell you one simple example why the model building or what is regression part. Uh, let's say what we will do is our main target variable over here is amount spent, right? What is your target variable? The variable that we are interested to predict. As simple as that. The target variable is variable that we are interested to predict. So in this case, I can say my problem statement as I need to build a machine learning model which will predict the amount spent by using number of clicks, pages viewed, time, right? I'm interested to build a machine learning model which is amount spent by using this n number of independent variables, right? So independent variables, a terminology alert over here for you guys. What is independent variable? Independent variables are the variable that we use to predict the target variable. So in this case, day, browser, number of clicks, pages viewed, time are your independent variable, and amount spent is your target variable that we are interested to predict. Now, let us see one scenario how your statistics will help you out in uh, taking up the decision. So what I'll do is I'll find the correlation. So correlation between amount spent column, comma, time in minute column. The correlation is 0.57985. Amount spent and time, right? Uh, let's see another part, or let us take it over here. Yeah, next part. We'll see correlation between your amount spent and pages viewed. So let us use that formula again. Is equals to correlation between your amount spent, comma, your time. Sorry, not time. Just a minute. Correlation between your amount spent and this pages view. Is the length is not same. So it is 0.68922. Now again, the correlation between other, if you find, suppose this is amount spent and pages view, right? Number of clicks. Suppose it is 0.92, 0.92 between amount spent and number of clicks. So what you can say from this analysis? What is your understanding? Yeah, I can understand that amount spent has higher significance, higher relation with your target variable, which is number of clicks. Can we say like this? Why it is high? Because it has higher impact. So your amount spent column is that particular column which has very high impact. So if you change amount spent, your number of clicks is supposed to change significantly, right? This amount spent and time, it has less, only up somewhat up to 60% correlation. What it means is the amount spent column is and time column. If you change time, let's say your amount spent is supposed to change only 60%. 60% means is only 60% related to your amount spent. And on the other hand, pages viewed is 68% significantly related, correlated with your amount spent column, right? So the reason why we are interested to go with the correlation first is we are interested to check which column is important for us and which column is least important for us. At this point of time, we only have 7 columns. So we are not interested to drop any columns out there. But here I'm introducing another term which is known as dimensionality, which is related to your size of the data. So dimensionality is nothing but number of features that you have, number of columns that you have. Suppose you have 100 columns in your data, so your dimensionality is very high, right? In this data, we have only 7 columns, so we are not interested to drop any column out there. So we'll not do that. But in real case scenario, we have 100 columns, we have 500 columns, we have 1,000 columns in your data. Data is this much heavy. You have to optimize that data. So what we do is every column is not important for us. We go with the correlation matrix correlation analysis. And from that correlation analysis, we understand that we can drop the least significant column. Let's say I have different columns which has only 0.2, 0.1 correlation. So I understand that in very rough sense, I can remove this column. But again, this correlation is not the only term which we consider to drop the column. But yes, correlation will help you out to understand the importance of that particular column, right? But it has some drawback, right? Can you think of this drawback? What is your drawback of your correlation analysis? What is that thing? What is something which we are not expecting, we are not getting from this correlation analysis? Can you guys think on this? Correlation has limitation. It is in mathematical sense to give you guys a hint. You have to think in a mathematical sense, not in technical sense. Some column have strings. I have not considered the string column, right? We cannot find the correlation for the string column. So that is not a drawback. We cannot find the reason why we convert string into numbers. I'll give second reason. First reason, I told you your machine learning model will not digest, your computer will not understand the text column. Second is you cannot perform statistical analysis on your text column, on your categorical column, right? Is it clear, everyone? Now coming towards your question, I'll give you some time to think on this. Why correlation is not only relate with one variable? Okay. If somebody cracks this, no, it will be very, I mean, I'll be very surprised. It is showing now in numbers, but what will be the relation? Surendra Kumar, you are going in the right direction. It is only showing in numbers, right? But I'm expecting some different line for this. Can you just modify your answer? Okay, I'll give you 1 or 2 more minutes. You can think on this, and then we'll see. Okay. So uh, I have got correct answer for that, for this from Surendra Kumar, but I'll just refine that answer, right? Uh, See, what he has given is he has told, uh, it shows how much percentage it is related, but it does not tell how it is related. Now, see one thing. You only know the extent in which it increase or decrease, right? You only know, uh, for example, amount spent and time correlation is 0.72. What do you mean by this? If you increase your amount spent, your time will increase. So this is time, this is amount spent, suppose it is increase. 0.7 means somewhat weak correlation. If it is, let's say, between amount spent and number of clicks, it is 0.98, suppose. So the extent is very high. If you increase it, it will increase again, but the slope will be high or extent is high. But it does not tell you, it does not gives you an idea if you increase this amount spent, by how much factor your time will increase. Can we get an idea about this? If you increase the number of clicks, by how much extent uh, your other variable is increasing? So this is known as strength between the variable. We do not get an idea about the strength between the variable. So I can write down over here is, uh, it only tells you if one variable is increasing, other variable is increasing or decreasing, but does not tell you in what extent it is increasing or decreasing. In what extent it is increasing or decreasing. So what we do is we make use of regression. So we can put this heading over here: correlation versus regression. Correlation versus regression. So correlation has restriction. This is your restriction, but regression does not have this restriction, right? So to understand the strength between the variable, we make use of regression, and regression is nothing but your straight line equation. Then it comes y is equals to mx plus c into the picture, and we'll see the slope, we'll see everything related to that. That comes under your regression part. So that's why in model building, we have to make use of regression kind of thing, so that it will tell you, the uh, extent in which it is increasing, right? Now, here itself, we have, okay, this summarizes your step number 4. Now let us go to next step, which is your step number 5. Let us go to step number 5. And this is again very interesting. I'll ask you a few questions on that. So what is the step number 5? It is model evaluation. Now, it's not like if you only create a model, you'll directly use that into your evaluation. It's not like if you create this model, it is working very fine, right? You have to check that. How do you check that? You check the performance of the model. So we have to check evaluation of the predictive model out there. We use several terms, we use several tricks, formulas to evaluate the performance of the model, right? Because it's not like if you just create a model, machine learning model, which will predict the price of a amount spent, which will predict amount spent. but it's not 100%, uh, you're not 100% confident to use that in your unseen data or in your new data, right? You have to basically check the accuracy. You have to check R2 score for that. You have to check RMSC, error part. You have to check a number of things over here so that you are uh, you will be confident in implementing that particular model to your project, right? So to give you guys an idea, suppose what I'll do is I'll just draw a simple line, and suppose this is your data. Let's do it. Suppose this is amount spent and this is time, right? And you have plotted the data on your X and Y axis, your Cartesian coordinates. X, these are the data that you have, right? Now what we do is we try to draw a line which will fit this data point. So in other scenario, you might have seen this figure. What is linear regression? It is nothing but you plot your data and you'll try to fit a model. It will try to fit a regression line on your data, which will try to fit all the models. So this is your hypothetical case because you will not be having a line which will fit all the data points, right? It's not the case. It will not happen 100%. You are 100% confident that it will not be the real scenario. Now, what is the other scenario? Now, see, there is something which is known as residual or error. What is that? The line, uh, this regression line, which is, for an example, the distance between the regression line and your data point is known as error, this line. So your best fit line is that line which is having minimum error. So for an example, if you draw this blue line, your error you have calculated, it is somewhere between 2.345. Again, you have drawn another line. Let us consider it as yellow line. Suppose this is your another line, and you calculated the error for that yellow line, and that is coming out to be 2.1. And similarly, you draw another line which is very best fit. Suppose let's say green line, this one. So it has error minimum 0.15. So what can you say for this is my best fit line. Now, again, coming towards your technical part, the error that we calculate, it is not just the, for an example, let's zoom it little bit. Suppose this is your line. This is your line. And these are the data points that you have. 1, 2, 3, 4, 5, 6. And this is your distance between the data point and the regression line. This is your distance between data point and regression line. And this is known as error. So error, you do not simply calculate just by adding this error, because the data point which are above to the regression line are considered as positive. So this data point, the error is positive over here. And over here, it will be negative. So there might be chance that your positive and negative will cancel each other. For an example, this error is 3, this is 4, this is 5, this is -5, -4, -3. And if you simply take summation of the error, it will be 0, right? You try this. 3 plus minus 3, 4 plus minus 4, 5 plus minus 5, this is 0. So your error will be 0. But in this case, it is a false alarm for us, right? The error is not 0. So what should we do for this? There is something which is known as residual sum of square. So we take sum of the square, sorry, sum, we take square term and then we'll take the sum of that. That is known as root mean square error. So 3 square will be 9 and minus 3 square will also be 9, right? So 9, 9, then 4 square is 16, minus 4 square is 16, pi square is 25, minus 5 is 25. And then you add this and then you square root of that, it becomes square root mean square error, right? So this will be your root mean square error. And in a technical sense, or in what is your expectation for this root mean square, it should be as minimum as possible because it is a error, right? So accuracy should be high for a good model. R2 score, it is similar to the fashion of your accuracy only. So R2 score and accuracy is analogous. R2 score, I'll tell you in brief sense, in more technical sense after some session. But R2 score is also somewhat related to accuracy. And RMS is your error, so that should be your as low as possible, right? So these are the different tools that we use to evaluate your model. So they are known as model evaluation, and which is also very important part, because if you get some low accuracy, if you get low R2 score, you cannot put that model into your business scenario. You cannot use that. So you have to increase the accuracy by using some different terms, different technical domain knowledge to increase the accuracy, right? So this is again really a challenge itself. So you increase the accuracy by using different terminology or your domain knowledge, right? And last but not the least, your step number 6 comes into the picture, which is very simple. It's just your model deployment. So earlier, if you see scenario 10 years back, if you just see scenario, a data scientist guy or machine learning guy, they are only interested or restricted their knowledge up to the technical term, which is more towards statistics, machine learning, and programming. That's all, and analysis. But nowadays, you should know some knowledge about the operations as well, which is DevOps, we consider. You guys might know this thing to deploy this machine learning models into an environment. It requires a different technical knowledge, right? So earlier it was fine to have just this knowledge, but nowadays it is essential for us, or it is essential for analyst, scientist, or machine learning engineer guys. They should have a sound knowledge of some cloud platform as well. So you take any cloud platform. I'll suggest you to go with Amazon AWS, or you can go with GCP, Google Cloud, or we have Azure as well, Microsoft Azure. This is Microsoft product. This is Google product, and this is Amazon product, right? So you should have this understanding because it's very, very essential. You should know how to deploy this project by using cloud environment, and somewhat sense of ML operation, ML ops, which is also in a trend nowadays. It is your essential skill. This should be a compulsory skill that a data scientist should have. What is ML ops? Similar to the DevOps. What they do used to do is DevOps means nothing but just your deploying part of your model, right? So it has software background, but when it comes to only your machine learning applications, there's something which is known as ML ops. So this goes hand in hand, but DevOps has other software use cases as well. But in MLOps, we strictly deploy the machine learning and data science projects, right? So you should go with the MLOps. I'll tell you few keywords as well, which will be very, very important for you. You should have understanding of RAG. You should have understanding of LLM ops. So these are some advanced technical terms which are in a trend nowadays. But in order to understand this, you should be having sound knowledge of your fundamentals. So that is not something that we should not look into, right? Fundamentals you should brush up, and then after that you should study this llama index. There are a number of things which I'll be suggesting you guys to go through. But that at this point of time, why I'm explaining this is because some people, what they do is generally they only restrict their knowledge up to this part, deployment part. But right now, because it is continuously changing, you should know the uh, advanced part as well. There's something which is there's one more thing. Um just a minute. Give me a minute. Okay, I mean, as we progress in our session, I'll tell you a few important topics as well that you should focus on. As of now, this is fine. Yeah, so this summarizes your machine learning or your entire CRISP DM framework, which should be a basic, or you should be a first part to start with your journey in this field or in this domain, right? Now, I have some chat. Is my voice breaking, guys? Is it for all or is it for only? Can you please let me know in the chat?
No, sir. It's very clear.
Okay, okay, fine. Now you go through this. If you have any questions, we'll discuss that. We'll have a short break, and if you have any questions, we'll just have discussion on doubts, your questions and your doubts. Yeah. So you go through this. I'll have 5 minutes break, and then we'll see the next part. Yeah. Anybody, if you have any questions, if you don't know, I mean, if you don't understand anything, you can let me know in the chat. All right. So let us discuss some questions. Is the data cleaning the same as data pre-processing? Yeah, the moreover, the steps are same only. So they are known by different names. We have data pre-processing, we have data cleaning, we have EDA, right? But moreover, EDA is the main heading that we have, exploratory data analysis. Under that, we have some steps which are nothing but data cleaning, data validation, data pre-processing, right? We'll be learning those cloud platform in this course, or we have to learn additionally by our own. Platform. If you see your syllabus, I'm not sure about that. You go through your syllabus. If it is there, so it will be there in your curriculum. It will be there in your course as well. Please, my kind of information, please slowly. As of now, understand very well in the upcoming list. Okay, Navin, yes, we'll go slowly only. We'll go in this space only, don't worry. Sir, in computer language, is Python is sufficient for AI/ML? Yes, Python is sufficient, but you should have basic understanding of R as well. So R should be your only basic, not will not use R in developing machine learning models, but only basic is sufficient for your R. So parallelly, you should focus on R as well. But Python is something we will go in deep, right? Fine for me, not clear. Okay. All right. So this is what we have. Now, what we'll do is we'll see some examples of regression, classification, clustering, which we have discussed in the machine learning or model building part, right? So I know you might have an idea about this, but for those guys, we don't who don't have any idea about different machine learning applications, we'll see that. So very first thing, linear regression or regression. What is regression? In regression, we have an example like uh, linear regression. We can have an example like we are predicting. In this example, we can take predicting amount spent in rupees or predicting price of a bike, or predicting price of a house. Anything could be there. Uh, we can also predict scores of a student. So it can be anything. I'm just giving a few example about that. In regression, what we do is the output variable that we have is always a continuous. So if I say regression, the output variable, the target variable that we have is a continuous variable, right? Now, next type we have a classification where your output variable is categorical. Output variable is or to be predicted is a categorical variable. For example, we are building a model which will predict the email, which will predict the email as spam or not a spam, right? So I can write down this example as classifying uh, incoming emails as spam or ham, right? Now, we can have another example of clustering, which I have discussed in unsupervised machine learning model. So clustering, we don't have any knowledge or any idea about the target variable. So no predefined notion of a label or of a target variable, of a variable which we are going to predict, right? So it is allocated, we allocate different groups or clusters formed, for an example, customer segmentation, right? So obviously we are going to learn in detail about this in our entire course, but this is what we have. So we use past data in supervised machine learning model that are nothing but supervised machine learning model are nothing but we use past data with labels is used for building the model. Past data is used to build the model. In unsupervised machine learning model, we do not have any past data, or we can say no predefined labels, no predefined labels are assigned to your input data, right? All right. So this is what we have for the applications. So to give you guys an idea about clustering, do you guys have an idea about uh, news article in segmentation? You might have gone through this. Do you know this in shorts application wherein we can read some data or where we can read news articles? Yeah. So in short, if you go now, you can see that in this application, if you download this application in your mobile, you can see that it has different segments. Here you might have new international news. Here you might have politics, right? Here you might have sports. Here you might have different category entertainment, right? So how they do is they classify this into different clusters. Segmentation is there, right? So this is a classic example of your clustering. Now, this is what I'm talking about. Yeah. So basically, it's a mobile application, so it will not work properly in desktop. But you can see over here we have different criteria, categories, right? So uh, in a single page, you can have different criteria. Second example, I mean, second important point I would like to highlight is this is not related to machine learning now, but if you go in upcoming session, you are going to learn deep learning, NLP, natural language processing, right? So a classic example of NLP model which restricts any text into certain uh, amount of words. Let's say we have 200 words restriction for this model. So if you see this application is a classic example of this limitation of any news into 200 words. So we use RNN model for this recurrent neural network, which is an advanced part. But to discuss in very lighter note, we can just see this example. If you see any of the news out there, it is not beyond certain limitation of the words. For an example, 200 words, right? It's again very interesting thing. You see, it's very less. You go any article out there, they have summarized this text summarization is used over there in NLP, and they have summarized this news into, let's say, 200 words or 100 words out there, right? All right, so this is an example of segmentation, clustering. So likewise, we can have different examples as well. Now we'll download the Anaconda for to kickstart our journey in Python, right? So do you guys have Jupyter Notebook in your system? Do you have Anaconda in your system? Everyone? Okay, let me just check just a minute. So in session one, we have the introduction of AI ML basic workflow that we have done. Then machine learning projects, introduction to deep learning and difference between ML and ML. Okay, we have discussed this. Let us go with the installation part in today's session. And in next session onwards, we will start with the basics of Python, right? Now, I don't have anything. So Visual Studio. Visual Studio is fine, but you should have Jupyter Notebook as well, so that we generally widely use Jupyter Notebook when it comes to machine learning part, right? So anyway, if you are good with Visual Studio, that is also uh, fine. Spider is also fine, but I want you guys to have hands-on practice of your Jupyter Notebook as well, right? So everyone, you just search Anaconda download. If you search this, you can go to the first link. Just select the first link, and you can skip this registration, and you can download based on depending upon your operating system. You have Windows, you have Mac, you have Linux. If you have Windows, you can select this link, or if you are using Mac, you can go with this. So it's 912 MB, 900 MB. It will take some time. And once you are done with the downloading part, or if you are getting stuck somewhere, if you are not able to download this, you can let me know in the chat. So what I did is I search download Anaconda, this one. I have gone to the first link, then I have skipped this registration, and I have selected the Windows option. You can download that. In the upcoming lectures, we'll teach the course of ML. Yeah, first there will be Python, and then we'll start the machine learning. So the flow, if you want, it is like this. So session number one, this was our session number one. Current trends I have discussed, what you should learn. Then we'll start with the introduction of Python, then introduction to Python advanced. Then there will be pandas for data handling, then SQL, and then you have EDA with Python, data visualization with Python, and machine learning refresher. We'll start machine learning in module number 8, which is a session number 14, 1 4. Do we need Jupyter or is Visual Studio okay? I will suggest you to go with Jupyter Notebook as well. See, if you are good with Visual Studio, you can have that, but you should learn Jupyter Notebook as well. I have Jupyter Notebook, no Anaconda. See, Anaconda is nothing but it is a package in which you have different uh, software, we can say, or we can say IDLE. So we have Spider, we have Visual Studio Code, we have Jupyter Notebook in a single framework itself, which is known as your Anaconda. So that's why we generally download Anaconda first in order to use your Jupyter Notebook, right? So I'll just open the Anaconda. I'll just launch the Anaconda so that we can see how many different applications that we have inside that. Yeah, you guys go with the downloading part and let me know if it is finished so that we'll see the installation. Now see, I have just opened Anaconda Navigator, and here if you see, we have Jupyter Lab, Notebook, Oracle Cloud, Infrastructure, IBM Watson Cloud. We have VS Code, we have Spider, right? So in a single platform, you have everything. And whatever you want, you can launch this. Suppose you want to launch VS Code, you can launch this. You want Jupyter Notebook, you can launch this. Yeah. Okay. We'll wait for others, Navin. If I get response from many of the candidates, we'll see. Yeah. Yeah. One more thing. The thing that we have discussed, the recent trends that you should be aware about. Uh, Let us see some uh, job description, and let us see what are the different things that we should you guys should be aware about, right? So for very first thing, you should know the generative AI terms, ML ops that I have discussed, machine learning, which uh, fortunately you guys have this in this course. Then apart from that, we have several libraries, machine learning frameworks. We have TensorFlow, we are going to learn that, PyTorch, sklearn. Then large language model experience you should have. LangChain, which I have forgotten. You should know this. You should know Llama Index. And as I've told, deployment you should know. So there are different frameworks in which, or the framework that we use to deploy the machine learning model. So we have Fast API, we have Flask, we have Django, right? Deployment expertise should be there. Hands-on experience building or deploying and maintaining AI/ML models in production. And these are the different skills, communication, and that should be fine. So the main thing that I want to highlight is generative AI. You should start MLOps. Then frameworks are important. We are going to learn this. So this is not something that you need to uh, start learning by yourself, But you should know LLM, that obviously will be our last session, our last module. Fast API, Flask, Django. I'll share some playlist as well, YouTube playlist. You can refer that to study this. And this LangChain and Llama index, this is also very important. You should have an idea about that. So fortunately, in our syllabus, if you see in our course, you guys have prompt engineering. So it covers your generative AI topic. The outcome of prompt engineering which will cover your generative AI part. LLM will convert your complete your LLM part. Prompt engineering will complete your LLM part, and you have the uh, attention mechanism, encoder, decoder, transformer, fine tuning, transfer learning. That is also fine. LSTM GRU, this is also very important. So the extra thing which is you might have to start by yourself after completing this, which is required for the industry as well, which I'll share basic idea about that will be which will be ML ops, and here we'll see LangChain model and Llama index, right? So we'll see this. I'll tell you few important points about this as well. Yeah. Now coming towards your download part, if it is done, you can let me know. Is it done, everyone? Done with installation. Thank you. Okay. Uh, okay. You can share your screen, anyone, and we'll see the next part. How do you install that? Right. So anybody, if you have an access, you can share the screen. Yes, anyone can share. All right. Go next. Can you share your entire screen? You are sharing only single screen, no? Yeah. Go next. Next. Create shortcut. Yes. Go next. Yes, Ari Woli, if you want this in a slides format, this was just an introduction, right? Today was just an introduction. So I have not used slides or I have not used a whiteboard. But from the upcoming sessions, I'll be using whiteboard, or either I'll be using whiteboard or I'll be using the slides, right? So you guys will be getting slides as well. So it will be flow wise and you can revise that. This was just being an introductory part, first session. So I've not added the slides or I have not used the slides. Yeah, go next. Finish. Right, this is installed now. Now, in order to use this, you can go to search bar, or it will, yeah, it is initializing, it will open directly. Yes, what about other guys? Do you find any difficulty in installing the part? Yes, anybody is having any difficulty with the installation, you can let me know in the chat. Now you can minimize this. Your Zoom icon, no, we have a black screen for that. We cannot see. So wherever you have that Zoom icon, you can hide it, or you can press to the right hand side. Remind me later. Yeah. Maximize this thing. All right. No, do not show me again. Huh? Now see over here, you have PyCharm, which is again an a Python IDE that we use for data science. We have Jupyter Lab, which can you go to that Jupyter Lab? Not Jupyter Notebook Lab. Yeah, don't launch, don't launch. So this is, I told don't launch. You have launched that. See, this is an extensible environment for interactive and reproducible computing based on Jupyter Notebook and architecture. So basically, whenever you are doing simultaneously, suppose you are a team of five and you're working on machine learning project simultaneously. Suppose you are doing some changes and you want that to be reflected to your other team member, so you can use that, which is known as Jupyter Lab. So it is a more lively connection, we can say. But Jupyter Notebook, on the other hand, now go to Jupyter Notebook. So it is your offline part of thing, which is only restricted to that particular user, right? So it is not uh, the changes that you have done is not, it is not reflected to the other team member, or he or she cannot see that. So this is just an offline part, right? And other, we have Spider, which is also Python. You can work in Python. We have VS Code. You can use that to do some coding. And we have R Studio, which we use to work with the R programming language, right? So R Studio is widely used. Jupyter Notebook is widely used. And this varies basically uh, depending upon person to person. It varies. So somebody will like VS Code, there would be some uh, candidates will like Spider, or personally I like Jupyter Notebook, and which we widely have used in the industry as well. So I'll suggest you to have hands-on practice of Jupyter Notebook first, and then if you are wishing for other IDEs or softwares, you can go for that. So you can go for Spider, you can go for VS Code, or you can go for the first one, which was your PyCharm, right? But Jupyter Notebook is something that you should learn from the basics. Now, how do you launch this? See, press that launch button now for Jupyter Notebook, and it will ask you for the default browser that you are looking to use. So whenever, just don't do anything. Whenever you are trying to open Jupyter Notebook, it will open by default in which browser you want to select that. So now you can select Chrome and go always, or you can select just once. Anything is fine. Now, every time if you open Jupyter Notebook from this point of time onwards, it will open in your Chrome browser, right? Now, maximize this. Yeah. And scroll to the left. Okay. So here you have This is your user interface for your Jupyter notebook. Now we'll see how do we create a folder, how do we create a new Python file. We'll see that. But I want all of you, you should create a separate folder for data science GUI, right? The reason why I'm saying this thing is because if you see in this your system C programming, if you see in your C file, C drive, if you don't save this in a particular folder itself, if you don't organize that, you will be able to, it will be very difficult for you to just search that particular file. But instead of that, if you just create a separate folder, and if you create a separate folder for Python, if you create separate folder for machine learning, if you create separate folder for uh, let's say pandas library, so segregate this out so that it will be very easy for you to find this in your local repository, local drive, as well as over here. Now go to your upload button, right hand side. Can you see that upload button? Yes, upload. And sorry, not upload, go to new. Upload here is you can upload different files. Go to new, last option, new folder. Now untitled folder will be selected. Yeah, click on that. Now how do you rename this? You can rename this, let's say as data science GUI. Hmm. And yes, and open that. How do you open that? Double click on that. Perfect. Now here we'll create different folders out there. So here we'll create Python, we'll create pandas, we'll create different thing. So you create one more folder over here, new folder, write down Python. Yeah, create one more folder now for machine learning, and create one more folder, let's say for deep learning, right? So this is your Jupyter notebook. Now I want you guys to do same thing. And if you are getting stuck somewhere, you can let me know. The new folder name is deep learning, right? Now you create your new, open your new tab on Google Chrome. I'll share one more thing with you. Now write down Google Colab. Google Colab. Yeah. Now what is this thing? This is uh, a Python IDLE, which is created by Google, and it is a live basically. So you don't need any software, you don't need any installation part. You just simply work on this. You, if you open Colab, so it works on Google Cloud, right? So everything will be stored on your Google Drive. You don't need to have an offline software for this, which saves our installation part, right? Just zoom out little bit, this your screen. Or is it 100? Okay. Okay, that's fine. Now here, uh, go to file. Here you can upload a notebook, create notebook, save your notebook, download your notebook, rename your notebook. You can do this, right? Now in edit, go to edit. You can cut the particular cell, delete the particular cell, and you can do some editing operation. Go to view now. View is nothing but, it's not widely used. Table of contents, executed code history. You go to insert now, to insert code cell, text cell, and go to runtime now. To run all the cell, to restart the kernel, we use this. To delete runtime, To disconnect your kernel from the server, you can do that. Tools are nothing but we don't use this, and help will be used to ask some questions related to this. Now we'll see some practical part. Now you go to start coding over there. uh, Here you have to write down the codes. So write down anything, write down print. No, it should not be now, it should not be capital. Why you are using caps lock? Hmm. Print, don't give space. After print, use bracket, round bracket. And write down in quotes, so single or double quotes, hello world. Right? This is your output. Now if you run this, you'll get, you will be getting the output for this if you run this. And to run this, you have one shortcut, which is shift plus enter. Shift plus enter we use to get the output. Right? So this is what we have. Now we are not going to do actual coding in today's session. Now, if you have any doubts, we'll specifically discuss that. So there will be a last 30 minutes, which is specifically restricted to your doubt session. So if you have any questions, if you have any doubts, if you want to discuss anything, we can discuss that.
Hi, Vipul.
Yes.
Arivoli here. Yeah, okay. Uh, 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 Today's session, right? So the first the five steps of workflow of a machine learning project. Is it applicable for is it the standard flow through for all the machine learning projects across the industry?
Yeah, it is standard one, basically.
Okay.
This framework is very generalistic framework. It is applied to all the machine learning projects out there, right?
Okay.
So first is business understanding, second is data understanding, third could be your data preparation, fourth is data model building, fifth is your model evaluation, and last is model deployment, right? So these steps, all the steps will go in this manner only. So there will not be change in the sequence when it comes to your framework. There will not be any sequence change. Yeah. And if you want this file, I'll share this file on the drive.
Is it like the techniques that you have used in today's sample data, for example, correlation? So there, I mean, uh, is it like okay, I'm just curious that whether there are other techniques as well that we didn't cover today, or like it's just for us to understand, give us a basic idea how the workflow goes. Is it something like that?
Yeah, yeah, yeah. See, basically, we will not discuss everything. We cannot discuss everything over here in the first introductory session, right? What we'll do is whenever we are going to discuss the model building part, at that time I'll be giving entire thing. We'll be discussing entire thing at that particular point of time. So this is just a basic overview of what we will be actually doing in the model building part, right? For example, data preparation or data cleaning. It is we cannot cover everything in very first session. In data preparation, whenever we are going to discuss data preparation, will there will be exclusive session for that, separate session. We'll discuss that in in that particular time. So this is to just give you guys an idea about the framework, how we actually go with the problem solving approach, right? This is just a framework. And for this each framework, let's say step number one, we'll be discussing that exclusively in our separate session, right?
Yep.
So you can consider this as part of your entire course, which you are going to learn this in this 6 months, right?
Yeah. Okay. Okay. Okay.
So I will be sharing this on your drive so that you can have a look at this. Additionally, if you go through the recording, you try to put this habit to create a separate notebook for this. And whatever important topics you find, you can write down that. So
Okay.
at the end of the course, everyone, there will be a separate notebook which will be created by you only, so that your time will you will be able to reduce your time of watching the recordings again and again. Because see, what happens is the recording goes for 2.5 hours, right? And if you see, we will be having uh, near about 150 to 160 hours. So to cover this 160 hours, supposed to revise this 160 hours, you cannot go back and watch each and every recording out there multiple times, right? What you can do is you watch recording twice or thrice, you write down your 10 to 15 or 5 to 2 to 3 page notes in your notebook. And then once you are confident in this, you're understanding everything. So what is there, what we have learned in the first part of this video, what we have learned in the second part is video, and what we have learned in the last part of the session, last 30 minutes. If you're confident in this, then you don't need to go and watch recording again and again. So indirectly, if you suppose, let's say, preparing for your interview, you will not be able to go to that particular recording, and you will not have to spend your entire 2.5 hours. You can simply do it in your 10 to 15 minutes over here, right? So similarly, for all the models out there, you have to do. And if you do this sincerely, while before your interview, you will be able to revise your entire course in hardly 1 hour, or your 45 to 45 to 1 hour, or maximum 2 hours. You can entire your and you can revise your entire course in your 2 hours of time, right? While actually spending 160 hours and watch recording again and again, that does not make any sense. So you can revise entire course before a day itself of your interview, and you will be able to touch all the concepts out there. So this is again very important part. If you do this, it will be very, very helpful for you. And if you don't do this, then again you have to spend your entire time to watch the recording and revise that particular part, right? So I'll not suggest that. Initially, you can go for recordings twice, thrice, or five number of times, but it's not suggested to go record for recording all the times if you complete this course. So it should be it will be always helpful to have your notes handy so that you can revise that at any point of time before your interview. Right? Is it clear now, everyone?
Yes, Vipul. And I have a doubt.
Hmm?
So, while discussing, we discussed about LLMs, Llama chart, everything. So, based on my understanding, LLMs is used for module model deployment, right?
LLMs? No, no, not model deployment. See, what are LLMs in very simple words? LLMs are your chat GPT.
Okay.
Chat GPT is your large language model itself. Uh, you have Gemini, you have Copilot, right? That are known as LLM. So why they are important for us? Because now uh, this industry has evolved in such a way that nobody use the simple ML and deep learning projects out there nowadays. Everybody is interested to build their own set of LLM model so that it can be able to solve n number of applications, right? So we have open source of code for earlier versions of GPT, which they have made it available. So we just modify that. You need to have an understanding of that particular engineering, prompt engineering, and LLM part. So that's why it is necessary to have that knowledge. Yeah.
Yeah, okay, Vipul. So, what I was about to ask is, this course we will be going through model deployment as well. So, you told that cloud platforms are the current expectations of the industry for model deployment. So,
Mhm.
in this course, if we go through whatever you guys are teaching, can I able to pick up the cloud? The next version is cloud platforms, right? So, using this course, can I able to learn the cloud platforms as well?
Yes, obviously. You can learn that.
Okay. But for fresher, I mean, I'm new to this domain. So as a fresher, I will be using the techniques that you guys teach. So will does that impact my interviews in future? Because industries when they ask cloud, then I won't be that good in answering that, right?
No, basically what they expect is, see, as many of the candidates, they are fresher, they are starting their journey from the fresher itself. So as a fresher, if you don't have any experience, they'll not expect you to learn any advanced part, right? Obviously. If you start your journey as a fresher, so you should have a basic understanding of that. And if you get selected while working on the projects itself, you guys will be learning n number of things. Because what happens is, uh, there are you will find, if you land in a job, if you will find that many of the things will be uh, will be unknown for you. So it's not like if you complete this course, you guys will be having complete understanding of this, right? It's quite obvious. For an example, let's say you got a job in let's say you got a job as a data scientist, right? There will always be something that you will not be aware about. There will always be something. Not only in this field, you go to any field out there. So what they do is they will make you work on that particular project. You have to explore it by yourself. You have to put that habit. You have to inculcate that habit so that you can learn that thing and you can become expert in that particular project. Once that project is completed, again, suppose you are going to work on another project, you will find that for this project, you don't have any idea about this two, three terminologies. So what you'll do is you will again go and explore that. You will try to learn that and you'll become expert in. So it's not always that you know everything about the project, because nowadays also, whenever we are working on a project, we get a project, the project is assigned to our team. So we find that we also don't have an idea about RAG, we don't have any idea about LLM models, we don't have some idea about this part. So what we do is generally we explore that, we try to study that, we implement that in our project, and then we become expert in that. So it's not like you always have a knowledge about everything, right? So what they will expect you as a fresher is you should know that platform, but they'll not expect that you should, if they give you project, you will be able to do everything by your own. It's not that, the case is not like that. But anyway, you should have basic understanding, basic knowledge of cloud platforms, which I told, or other platforms which I told.
Yeah,
Uh,
got it.
yeah, perfect. Yes, Ari Woli, few topics like introduction to deep learning and difference between ML and DL, which is very basic. I think you have missed that. Introduction to deep learning, I told you, where you use neural networks. I told you that in short example, where you categorize your data into, let's say, restrict that text, summarize, it is known as text summarization. That is nothing but your deep learning part. And if I throw more light on that, as of now, you guys will not understand. That is very advanced part. So while going further with our journey, I'll be sharing few examples which is related to deep learning, right? How to choose AI project, we'll discuss that. I told you that particular example of using RNN network NLP model, in short example, that is a part of AI project itself. But in more technical sense, if I talk about that, you guys will not, it will be very heavy for you at this point of time. So I restricted that to only basic discussion, right? And inducing AI using ML and DL, I discussed this thing as well. Again, if I explain this in more technical thing, I see I have projects. If I explain that particular project, you guys will not able to digest that, right? So let us keep it very light at on the day one itself. So that's the reason I have not explained it in much depth. So I have just thrown a basic light about that, right?
Yeah, thanks, people.
Yeah, yeah, sure. All right, excellent. Then we will, if you don't have any questions, we'll stop here for the day. From tomorrow, not tomorrow, from next session onwards, I think we have to start with the Python, right? Let me check the next session agenda. What is there? All right. So basic of why Python is required. Python ID, which we have discussed in today's session itself. Hello world program, which we already have done. Variable names, strings, and basic list. We'll see this, right? Again, it will be very interesting. You guys will be doing this actually hands-on. So it will not be like I will be reading the code, I'll be explaining the code. I will do it live. I will write down code. I'll not use the already existing code, and I'll not just read that. Can you share the sessions? Sessions, you already have it in your portal. If you see this, if you go to your portal, you already have the syllabus, no? Class contents. So you can see that this file is nothing but it's a copy of your syllabus, which you find it on your Google portal. Right, Gopi? You go to that you go to your syllabus copy content section. If you see class contents, you will get the entire list of that. Okay, apart from this, if you have any questions, you can ask. just save this. All right. If you don't have any questions, we'll stop here for the day. And I'm sharing this file, Excel file with you, which you'll be getting on your drive, right? So I'll just add this file to the drive as well. Folder, say day one. All right, everyone. I have uploaded that on your drive.
Thank you, Vipul.
Do you have the link for drive? You guys have drive link, everyone?
No, can you please share that?
Okay, I am sharing this. Obviously, you'll be getting this from the coordinator itself. If you don't have, make sure you bookmark this so that you'll be getting the contents over there. So I have shared the drive link to everyone in the Meet. All right, then, everyone. Thank you. Happy learning.
Thank you, Vipul.
Thank you, Vipul.
Thank you, Lord.
Thanks, Vipul.
Thank you.